Hello everyone, I'm Domingos and I'm also called DMA and appreciate when I'm called DMA. We started a series on a function whereby we are now discussing polynomial function, specifically first degree order. So continuing from the exercise that we started in the last video, and if you didn't watch the first video, I recommend you to go and see that in our playlist to better understand this exercise. Okay, let's have a look at this exercise and see what we have. Okay, we have f of x equal to 2. It's also known as a constant function. We know that the first degree function has this form, y equal to ax plus b. B is a number, b is a constant. B is a constant, we know that, and a is also constant. And x is a variable, the independent variable. And now looking at the exercise number 1, what we realize is that we don't have x. This implies that a is 0. A is 0, and when a is 0, 0 times x is 0, because 0 times any number, it's still 0, always 0. We end up having b. So that means this function is this function when a is equal to 0. So sketching the graph of this function, we discussed in the previous classes that the graph of a constant function is always a straight line. So y-axis has positive side and negative side down here, and x has positive side and negative side down here. F of x equal to 2 is the same of saying y equal to 2. So we locate 2 here, 2 is here, and we make a straight line passing through the point. So that's the graph of f of x equal to 2. Now my question is, does it stop? This does not stop. This continues to plus infinity and this continues to minus infinity. Why? Because it's not specified the interval where x is defined. If the interval of x is not specified, that means they are considering x to be the whole real number. So that's what we have to do when it comes to those type of situation. X is not defined, and since the domain is all the real numbers, so that means that's the graph that we have for the first example. Okay, now what happens in the second example? We have f of x equal to 2, whereby x is defined from 1 to 3. So now in the second example, we have a condition for x. X is defined from 1 to 3. While in the first example, x was not defined in any specific interval. They just said, sketch the graph of y equal to 2. That's why that's the graph of the first example. Because x was not specified to be defined in a certain interval, that's why the graph of f of x equal to 2 is from minus infinity to infinity. There is no beginning and there's no end. So what happens now in the second example? In the second example, we have f of x equal to 2 from 1 to 3. What changes? Comparing both of them, what changes is the interval condition where x is defined. We don't have here in the first one, but we have here in the second one. So what changes is let's consider that 2 is located here, and x has values like 1, 2, 3, 4, 5, and so on, depending on where you stop. That's depending on the scale that you're going to use, unless it's specified, unless you are specified. Okay, now let's see. They say y is equal to 2. Y is the same as f of x. Y is equal to 2, but x is defined from 1 to 3. Normally, as we did in the previous one, we will just make a straight line that passes through 2, because y is equal to 2. But in the second example, it can't be done like that. This is true. I was just supposed to make straight line, but because of the interval condition where x is defined from 1 to 3, this is x values from 1 to 3, so that means my straight line is going to be like that. I will just put some bubbles, some points here to show my interval. So This is the straight line. Okay, let's suppose that it's beautiful, but it's not. Okay, it's okay. And that's the straight line from 1 to 3. Why I didn't continue to make equal to that one? Because in the second one there is a condition where x is defined, so I cannot go further. Okay, so now let's analyze the last example, which is that f of x is equal to 2 from 1 to 3. X is defined from 1 to 3 where the period is 2. Okay, what happens is now from f of x equal to 2 until the interval is the same here. What we have something different here is the period that was added, t equal to 2. Okay, since the period is equal to 2, what happens? What changes the exercises? Let's solve. Let's sketch. 2 is here. This is 1, this is 2, this is 3, 4, and 5, and 6 here. That depends on you where you stop. If you want to stop from, if you want to stop in -6 or 6, if you want to extend, depends on you. Unless it's defined, unless you are required to sketch the graph only from -7 to 7. If they state that, then it doesn't depend on what you think or on what you want, but on what it was requested. So, okay, the exercise will be applied here the same way we did in the previous example. Example number 2, which is f of x equal to 2, whereby x is defined from 1 to 3. Okay, which is the same graph here that I'm going to draw here. Okay, and now the period is just telling you that you have to repeat your graph several times. That's what you have to do. Okay, so that means I will repeat this graph several times. If we check from 0 to 1, they jump, so the straight line starts here. So I will consider again, like where it finishes in 3, like 3 is my 0. So from 3 to 4, I won't sketch the graph as it was here, from 0 to 1. So from 3 to 4, I won't sketch the graph, so I will start in 4 to 6. 4 to 6, why? 1 to 3 numbers, because there is also 1 to 3 numbers. So the same I will do the left side. When I repeat this here, from 0 to -1, I don't sketch, so I will sketch on those 3. So from -3 to -4, I don't sketch, I will sketch on these 3. So that means this is the graph for the last function. And how do I see that my period is 2? By subtracting the ending point from the initial point. If we say this is the ending point, this is the initial point, if I say 3 minus 1, this is going to be 2. That's the period that they gave, t. Now if I analyze it here, it's going to be 6 minus 4, which is 2. Even on the left side, minus 1 minus 3, it's going to be minus is plus, so it's going to be 3 minus 1, which is 2. And the same happens, so that's the period. The period was satisfied. So this graph is for the first one, and then this graph is for the second one, and this graph is for the last one when they add a condition. When they add a condition, that means you have to repeat what you sketched several times. You stop until the interval is reached. So if they say only from -6 to 6, then you sketch the graph from -6 to 6. But if they don't specify, then that depends on you. If you enjoyed the video, leave your comment, your like, subscribe, and also share with your friends. Thank you. I see you in the next video.